So today's topic is recurrent neural network, and I think I will start now. So if you have any question in between, you can ask me. So I'm starting. Hopefully you will enjoy this topic. And so before discussing what is recurrent neural network, we must understand what is neural network. I think you have a session on a neural network, and somebody has already discussed about neural network. But I think before starting recurrent neural network, I should discuss about the neural network, because my way of discussing neural network will be different. So let us talk about what is neural network, how do they work, and then we will talk about the architecture, because recurrent neural networks is related to architecture, neural network architecture, and then we will talk about the application of recurrent neural network. So what is a neural network? Actually, whenever you want to process something using computer, then you have to write program. Okay, so there are two ways of writing program. One is the traditional way, in which you have to write a step-by-step solution of the problem. And the other way, because this kind of method is very useful in solving, this kind of method is very good in solving computation related problems, where you want to do arithmetics like plus, minus, multiplication, division. But this kind of programming is not good when you want to recognize the face of a person, when you want to design a associative memory related thing. So what should I do in that case? Like, if we want to design programs for those things which are very easy for human being, but which are very typical for the computer because of its already existing architecture, what should I do? So several people actually, they have created another architecture and another kind of programming technique. So this is one of the technique which is called as neural network, and it can be used for solving those problems which are not easy and which don't involve computations directly. Directly means plus, minus. So those things are not directly involved. So what you need to do, you need to see other computational approach which can be mapped in the form of computer program, and that can be solved. So the another method of solving such kind of program is to use the processing used in human brain. So what we do in artificial neural network, we try to mimic the computing process which is actually used in our human brain. So that is called as, since this computing model is inspired from our human brain, so that's why we call it as artificial neural network. So what is the difference between computer program and our neural network? What is the difference between digital computer and biological neural network? So you can see, in computer we use deductive reasoning. So we apply some rules to process the data. And as I've already discussed that you have to write sequential program. So these programs are not efficient for handling those problems where human intelligence is required. And what is biological neural network? It works on inductive reasoning. So here we will use a number of neurons in parallel which will do some kind of computation. So it is an example of parallel processing technique. So biological neural network is a network of several neurons which are connected with each other and which performs some task parallelly. So artificial neural network is basically the simplified model of biological neural network which are connected with each other and which perform something by using some kind of computation. So we will talk about biological neural network. So why we use artificial neural network? Because these kind of networks are very helpful in solving those problems like face recognition problem, character recognition problem. And what is the advantage of using artificial neural network? They follow massive parallelism. So it means actually this computation is based on different neurons which process in parallel. So parallel computing can be used. So what we do actually, whatever problem we want to solve, actually, we want to distribute that problem on several neurons and we perform parallel computation. So this is called as distributed representation in computation. However, while writing program using neural network, we don't use deductive reasoning, means we don't use sequential method. We use another method which is called as learning ability. Learning ability, actually, there are two methods to train the existing model. Actually, artificial neural network is basically a mathematical model which we need to develop by using some methodology. So that is called as learning ability. So there are two kinds of learning which are commonly used. One is called as supervised learning, where you know the correct answer. So that is called as supervised learning. And another is called as unsupervised learning, where you are not clear about the correct answer, then you have to use unsupervised learning method. So this neural network has generalization ability. So once the neural network is trained, you can apply it and you can solve any kind of problem which is similar to the which is very similar to what you have used in training. There are several applications of neural network, so we will talk about those things. Let us see other things. So artificial neural network is a machine learning approach that models human brain and consists in number of artificial neurons. Neuron in artificial neural network tends to have fewer connections than biological neurons. So actually, when we use artificial neural network, actually we cannot map the exact model which is there in our human brain because of our computational limitation of computational architecture. So each neuron, so how we create actually model, actually in ANN we use different neurons, and a neuron receives input from the input units, and actually in ANN we use some activation function which will process input and which will produce outputs. So this is this is the process which is implemented in artificial neural network. So activation function is a, you can understand as a mathematical function, because whatever math program we want to write, we have to use computational modeling. So that's why we have to use activation function over there. So activation function is used for implementing plus operation, minus operation, multiplication, division, etc. It depends. Actually, many people are creating different kind of activation functions. So you have to see what kind of problem you want to solve. Okay, so depending on the problem, you can use different activation function. Actually, right now these activation functions are limited. So I will talk about the activation function very soon. And basically in ANN we use a mathematical model and we supply some training instances. We try to train the neurons, and once the neuron is trained, it will be able to produce output on a test input. So let us see. We don't want to discuss about the artificial neural network and biological neural network. So ANN is specified by neural model. So we have to define how many neurons will be required to develop artificial neural network, how they will be connected. So depending on the topology of neuron, we can define the neuron model. So this neuron model is very important when you are talking about recurrent neural network, and basically it creates an architecture. Architecture means how neurons are connected in three-dimensional space. So that will define your architecture. So in this mathematical model, first you have to define the architecture. Then for once this architecture is established, you have to define a learning algorithm which will train these neurons according to the given training instances. So once this whole network is trained, then you can apply it for a particular application. So let us see. This is the example of one neuron. So what we do in one neuron we supply inputs from various links. So this input may be supplied from the input device, or it may be supplied from another neuron, output of the another neuron. So what this neuron does, actually, it has three things. It will collect all input values. Okay, it will sum all the input values, and then it will apply activation function. So activation function will produce the output. So output is basically dependent on the activation function. So there are two kinds of activation function. One is called as continuous, and the other one is called as binary activation function. So depending on the type of output which we want to generate for our problem, we can use binary activation function or continuous activation function. So let us see how the neuron process the information. So here we have already discussed. This is the input values which this neuron is receiving. So you can see these are the x1, x2, xm. So these are the input values. So actually, whatever information is sent to neuron, it is already weighted. We have to assign some weights to these input values. And once the input is supplied to the neuron, the total input is checked at the neuron. So here you can see this is a summing function is used for collecting all the inputs. So you can see this is x1 is the input, w1 is the weight of this input unit. So what input will be transferred to this neuron, it is w1x1. Similarly, from the second input, what input will be transferred to this neuron, it will be w2x2. Similarly, because there are m number of inputs, so the total input will be w1x1 plus w2x2 plus w3x3 plus wmxm plus one byte is also added. So that will be the total input which will be transferred to this neuron, and once the input is collected, it will be transferred into the activation function, which will decide the correct output. So this is the model of neuron in detail. So here you can see, we can in short we can simplify this neuron as this one. Let us see one example. This is, so here you can see there are two input units, P and L, and the weights associated with these units are W and B. So the total input will be WP plus L. This is 1, actually this is plus B, so we can write WP plus B, and then the activation function will be applied on this total input, and then output will be generated. So that is A. So this is the simplest model. So you can see over here, if we pass, what is the total input? So that is WP plus B. So we are writing here under the activation function. So depending on the activation function, we can produce the output. So this is the example which can be used. So we are not talking about bytes and weights. It is, I think it is already discussed in the lecture which was given by another professor. What we want to discuss over here, these are the common activation functions which are used for solving problems. One is called as step function, as signum function, sigmoid, linear. So here you can see the function can be categorized into two categories. One is called as binary function. So here you can see the function is producing only two outputs. So that function is required when you want to solve some binary related problem. So here you can see again the function is producing two output, but the output is +1 and -1. So the signum function is used in those problems where you want to use bipolar encoding. This is called as bipolar encoding. This is called as binary encoding. This is sigmoid function. So here you can see whenever you pass any continuous value, it will produce the continuous output. So these functions are used in solving continuous function related problems, sigmoid function and linear function. Okay, now we are talking about the network architecture, because neural network architecture is very important in solving the problem of solving some real life problems. So there are 4 architecture which we use in solving different kinds of problem. One is called as single layer feed forward architecture. Second is called as multi-layer feed forward architecture. And third one is called as recurrent neural network. It is basically, recurrent neural network is basically different kind of architecture used for solving different kind of problem. So we are talking about single layer feed forward network. Then we will talk about multi-layer feed forward network, and then we talk about a recurrent neural network. So this is about single layer feed forward network. So the neurons are arranged in separate layers. Mostly when you are talking about single layer feed forward architecture, so whenever you design any network, 2 layers are compulsory. One is called as input layer, from where input will be supplied, and the second one is called as output layer, from where you need to produce the output. So when only 2 layers are there, then this architecture is called as single layer feed forward. Feed forward means there will be only unidirectional connections. Unidirectional means in the direction will be only in forward. There will not be a feedback connection. Only feed forward connections will be there. So you can see here we are using 3 units. This is first unit, this is second unit, this is the third unit. And from these 3 units, we are passing information to the output layer. So here, all 3 units are transferring information to all the neurons which are there on the output layer. So only 2 layers are there. This layer means the set of neurons used for some particular work. So input layer means input layer is used to transfer input to other neurons. So here you can see these neurons are used to transfer input values over here. Although if you have some additional layer, those additional layers are called as hidden layers. Hidden layer can also transfer the input, but here those the neurons which are directly connected to the input values are called as input layer. Will be defining the input layer. So the neurons, when we are talking about the architecture, the neurons will be arranged in separate layers. So 2 layers are compulsory. One is called as input layer and second one is called as output layer. In general, there will be no connection between the neuron in the same layer. So you can see in the input layers, neurons are not connected. So the neurons in one layer receive inputs from the previous layer. So here you can see the neuron of this layer is receiving information from the lower layer. So this is input layer. The neurons in one layer delivers its output to the next layer. So once the information is processed, this output may be transferred to the another layer. But here only 2 layers are used, and the connection are unidirectional because this is feed forward architecture. So there is only one direction which we are using for this connection. So this is the difference which we will talk about the recurrent neural network and feed forward. In feed forward, you will have only one direction, that is called as only forward directions. There will not be a feedback loop. In recurrent network, there might be some feedback loops. So that is the difference. So first we need to define the architecture which we want to use to solve the problem. If you have some feedback connections means once this output is transferred back to this neuron, then it will have a feedback connection. Okay. This is about multi-layer feed-forward neural network. Actually, those who are very good in solving problems using neural network, they must have some idea that only 2 layers will not be sufficient to model any real life problem. So you have to use more number of layers. So this is another model which we use for solving complex problems. So that is called as feed forward neural network, and generally we use multiple layers in defining the architecture of feed forward neural network. So here you can see in addition to input layer and output layer, there will be some hidden layers. So input layer is just for transferring input information to the hidden layer. Output is for producing output. Hidden layer, the output of hidden layer is not known to the programmer. They are used simply to transfer outputs to the output unit. So you cannot visualize what is happening at the hidden layer. This is feed forward. Feed forward means it will have only unidirectional connections, only in forward direction. So you can see the neurons of the hidden layer are connected to the input layer, and they are having only feed forward connections. Similarly, the neuron of output layer is connected to the hidden layer, and they are only having the feed forward connections. So this is multi-layer neural network. It is used to solve many problems. One very important algorithm which is used for training this neural network is called as backpropagation. I think you have already learned about these things. So this model is basically used in solving many real-life problems. It is the most common model which is used for solving several problems. Anyway, now we are talking about the recurrent neural network. So recurrent neural network, you can see FFNN means feed forward neural network is acyclic, where data passes from input to output nodes and not vice versa. It means in feed forward neural network, there will be only unidirectional connections from input layer to hidden layer, then hidden layer to output layer. There will not be a feedback connection. However, in recurrent neural network, we can have connections that go backward from output to input nodes. And mostly they are used for solving dynamic systems related problems. So why we want to have the feedback connections? Any person want to ask any question? Hello? Am I audible?
Yes, sir.
Yes, sir, you are audible.
Okay. So I think if somebody want to ask question, I don't know whether he can interrupt me or not. So if anybody want to ask question, please
Yeah, sir.
Okay. So we are talking about recurrent network. So recurrent network can have connections that go backward from output to input nodes. So where we require this recurrent network, in what kind of problems we can use this recurrent network, and why we should design recurrent network. So there are some problems where previous information is required to produce new output. So in those problems, we can use recurrent network. For example, you have seen many applications where, like in Gmail, when you are typing that how are you? So if you are writing how, then a word will appear are you automatically. So that is due to recurrent neural network. One recurrent neural network is placed, which is guiding like what output may be expected, or what words maybe appear when you are writing some emails. So we use recurrent neural network. So it is what is happening actually when you want to solve some problems where the next output is dependent on the previous input or previous output. Then you can use this recurrent neural network. So for example, if you are writing how and you have not written anything over there, so what is the expected output? So R may be the next letter, U may be the next output. So how you are predicting R, so that is on the basis of how, which is the output produced by the previous value. So for solving those problems, we can use recurrent model. So recurrent models are used where you want some feedback connections. You want to have some memory in your structure. So recurrent network can have connections that go backward from output to input nodes and model dynamic systems. In this way, recurrent network internal state can be altered as a set of input data are presented. It can be said to have memory because we want to memorize something to produce the next output. So that's why it may have some internal memory. It is useful in solving problems where the solution depends not just on the current inputs, but on all previous inputs. Actually, depending on the type of memory used for designing recurrent neural network, we can create many models. So if only one information is required, then the model will be different. If two words are required to like produce next output, that model will be different. So where we can apply this thing, we can apply this recurrent neural network in predicting stock market price, because you can see whenever you want to predict stock market related price, the current output will be dependent on the previous stock price. So that's why we use recurrent neural network modeling. Weather forecasting, current weather is dependent on the previous weather, so we have to collect previous weather related information for training this recurrent neural network. And as we have already discussed, it can also be used in natural language processing. So when you are writing some words, okay, you can predict what else may be added to form the correct sentence. So that's why it is called as it is used in natural language processing. So this is an example of a recurrent network architecture. So here you can see we have this. There are only two layers. One is input layer and second one is this output and hidden layer. So actually in recurrent neural network, you have different layers. So we are having over here, so you can see here, I'm sorry. So here we are showing different layers. So you can see this output neuron is connected to input and some delay is associated with it. So we are having a feedback connection over here. So that's why it forms a recurrent network model. Now, how many connections will be used to create recurrent neural network? It actually depends. So it is not necessary to connect each and every neuron back to the input layer. So if you can still connect some partial neurons, like let us suppose in this output layer we are having two neurons. One is this one and second one is this one. So it depends on your problem, means how many neurons from the output layers you want to connect with the input layer. So if only one connection is required, that can also be done. So here, because we are talking about the recurrent neural network model, so we have shown that in hidden layer is actually this node is in between the output layer, but exactly it is, if you draw it in 3 dimension, it is in between input and output layer. So you can also connect the neuron in hidden layer back to the input layer. So in total, this recurrent neural network has feedback connections. So that's why this architecture is called as recurrent network architecture. So whenever you are talking about recurrent neural network, there will be some feedback connections, and then you will be using some kind of algorithms for training it. So this delay is very important in certain problems. So those who belongs to electrical engineering, they can apply this recurrent neural network in solving load forecasting problem. So short-term load forecasting, so that depends on the delay. So when delay is less, then that is called as short-term load forecasting, long-term load forecasting. So those recurrent neural network can be used for solving those problems. In general, we can use this model for representing recurrent neural network. So that was the model where I've already discussed, like how can you form the feedback connections. But this is the correct model. So you can see what is happening over here. This is the weights, and you are passing some input over here, and you are getting the output. So this output, you can see this output is fed back to the another input. So here from this, you can expand this network architecture. So when you see this network architecture, what is happening actually, the new output is computed on the basis of next input and the output of the previous layer. So this output will be transferred as an input, and it is containing the next input will be passed to the next neuron. So this is happening in recurrent neural network architecture. So in this way, this is different from feed forward network. What is the difference between feedback and recurrent neural network? So feed forward and recurrent neural network. So what we are doing when we are implementing feed forward neural network. So in feed forward neural network, we are using several neurons for implementing one function, right? So I already told you that in multi-layer neural network, in multi-layer, let us see this one. This is. You can see here what is happening. Actually, there are three neurons at an input layer, 2 neurons at output layer, and 4 neurons at the hidden layer. So what is happening actually, we are supplying information, input information to the hidden layer, and some function is implemented with the help of this architecture. But we don't know what function we are going to implement. Similarly, when the input is passed from hidden layer to output layer, some function will be implemented over here. So what is happening in general, input is received and some function will be implemented and it will be producing some output. Then output will be transferred to some function and another output will be obtained. So that is the working of the feed forward connection. So you can see over here what is happening. The input is supplied, right? Then a connection of neurons will be used to produce output, which will work as an input for another network. So we are using different networks. So this network is formed due to the connection between input and hidden layer. So it is we want to implement some function with the help of that architecture, feed forward architecture. So here you can see that function is different for different layers. So we are implementing some function at first pair of layers, input layers and hidden layers. Then we are implementing the second function for hidden layer and output layer, or hidden layer to next hidden layer. So you can see in feed forward connection, different functions will be implemented by different layers. Okay, so we are passing some input, some function will be implemented and it will produce output. This output will work as input for the second function, and again it is processed to produce the next output, and this is happening. And finally you will get the final output. But in recurrent neural network, that is not the case. What is happening over here? Same function will be implemented by the different layers. So this is the difference. In feed forward network, you are implementing different functions at different layer, but here the same function will be used. The only thing which is different is the input. At each layer, we will be passing another input. So that is the difference. So here we are passing H0 and X1. When this information is passed to F, it will generate H1. So this output H1 is now transferred to the same function with some additional input. So in recurrent neural network, you will supply input and the previous output. So this is happening in the recurrent neural network. Any question about this? Am I audible? Hello.
Yes. Yes, sir. You're audible.
Yes, sir.
If you want to ask any question about this, okay. So this is about feed forward and recurrent neural network. Now, where we apply, like, where we can use this recurrent neural network architecture, in what problems we can use this recurrent neural network architecture. So I said that you can apply this neural network architecture, recurrent neural network architecture, in solving problems like short-term load forecasting, long-term forecasting. You can also design memories, associative memories, with the help of this recurrent neural network architecture. And this is the wonderful application of recurrent neural network. So let us talk about what is associative memory and what is the advantage of creating its associative memory and how it can be utilized in solving problems. So what is association? Because we are talking about associative memory. So associative memory means in human brain, actually human try to gather information which are very close in association. For example, if association means, let us suppose if this is the person, okay, and this person is the father of this person, so we can try to associate. Hello. Any problem?
No, sir, you continue. Somebody mic is on, I'll off it.
I don't know. Anyway.
Excuse me, sir. One doubt, please. Can you show that RNN layers?
I already shown you the different layers.
Yes, sir. I have a doubt in that because that before that, sir.
This one?
No, sir. Before that.
This one?
Yes, yes, sir. In this layer, in the first, no, sir. Next one.
This one?
No, sir. Next one.
I have already this next one.
Yes,
one.
sir. No, next one, sir. In between that, two figures was there. Yes, sir. This one. Sorry, actually, in this the first diagram, if it is after the unfold one, actually, is it like this is the same neurons in the same layer? I mean, in the same layer, these are the different neurons, or does it represent the different layers here?
Which one?
The x of t minus 1 is the input for first neuron. Xt is the input for second neuron.
This is the generalized model, actually, the generalized representation of recurrent neural network. Okay. So it can be used, actually. This is the extension, like how this generalized representation can be extended.
Okay, so does W represent the weights itself? Is it like weight is transferred?
Yeah, correct. Yeah.
Oh, okay, sir. Okay. So it is not. This is representing different layers. It is not the same neurons in the same layer, right? You're not communicating between the neurons in the same layer.
I already shown you the different architecture here. From here, you can start, like, you can see what is happening. So this is the generalized. This is the method, right? Where actually in recurrent neural network you will have some feedback connections, right? So some information will be transferred back to the input layer. So we are using the same kind of modeling over here. So what is happening over here, actually we are transferring information back to the previous layer. So that is
that I understood. Okay, sir. Okay.
So we are talking about any problem with this one, like feed forward and recurrent neural network architecture. The difference is here we are implementing different functions at different layers, right? Because if there are several layers here, we will be using the same function. And next, hello.
Sir, I have one doubt. Sir, I have one doubt.
Yeah.
Sir, in recurrent neural network, memory is used. So memory used in every layer or at a particular layer?
Memory is what actually when you are creating a feedback connection, okay?
Sir.
So that will
Sir.
work as a memory for that, right? So
Okay, okay, sir.
whenever
Okay,
you are feedback means what is happening actually, you are connecting the previous output to back to the input, right? So that will create some sort of memory.
Okay, yes, sir. Okay, sir.
And okay, so now we were talking about the associative memory. So here I was talking about the association. Association is what? You try to collect things on the basis of association. For example, if let us suppose if I'm checking the face of a particular person and he's my neighbor, I can identify his father because they must have similar kind of architecture. There might be something which may relate the son with the father, right? So we are associating the things. So in associative memory, actually, we try to associate patterns. So we want to form connection between input and output. So there are two kinds of memory. Let us see this one. Okay. So what we do, let us suppose if we have this connection like 1 0 0 0, this is the input, and let us suppose this input is associated with the output 0 0. So we are forming association that once you find 1 0 0 0 as an input, the output will be 0 0. So we are connecting some association between input and output values. Now we are defining 1 1 1 1, and let us suppose we are connecting with this information with 0 1. So this is how we can form association. So what we want to do with the help of recurrent neural network or feed forward neural network, so we will design a neural network and we will supply input and output pairs. So these are the input and output pairs. We will train our neural network. So once it is trained, so when you supply, what will be the output corresponding to this 1000, it will correctly produce that the output class of this 1000 will be 00. So this is called as forming association. So whatever the network has already seen, okay, the network can remember all that information and can reproduce it. So that is called as associative networks. So here you have to form the association. For that, you have to supply input and output pair. You have to create the architecture, because I already told you that you can use two kind of architecture. Either feed forward connection can be used in this architecture. So you can use feed forward connections or you can use recurrent neural network. It depends on the problem. But the problem is simple. If you want to form association between two values, then you can use this neural network architecture. So recurrent neural network can be used for forming associations between the input and output. So we can have similar kind of associations, like, for example, what is memory? Memory is what? Let us suppose that we have seen this information 10000, and we know that 1000 means we have already seen it. So this, let us suppose, what will happen? Let us suppose we want to recall that whether we have seen this 1000 or not in our pattern list. So if we can recall it, then it is called as we are having some kind of memory. If we are not able to recall whether we have seen 1000 in training instances or not, then we will say that we are unable to store any information in our brain. So actually we can form a association between input and output, so we can recall it later. So if we are forming an association between the same input and the same output, then it is called as homogeneous association. When we are connecting different entities, like at input, let us suppose this is 1000. This is, let us suppose if this is 1000 and we are associating this input with the output, which is inverted of this input. So this 0, 1, 1. If we create a network which can do this kind of activity, then this is called as heterogeneous association. So here you can see input and output is different. So that kind of learning is called as creating heterogeneous associations. When we are associating the same input with the same output, it is called as homogeneous association. So we usually use a recurrent neural network and the feed forward also for such kind of designing associative memories. So let us talk about something. Associative networks are able to store a set of patterns. Patterns means there will be some connections, some inputs and the corresponding output. And what you have to do with the help of neural network, you have to remember those inputs and outputs. You need to train your network so that it can learn like which input is associated with which output. So that kind of learning is creating associative memory. So associative networks are able to store a set of patterns and output the one that is associated with the current input. I have already discussed with the example. The patterns are stored in interconnections between neurons, because whatever we want to solve, actually with the help of neural network, that information must be stored in the interconnections. So we cannot use any mathematical function, only interconnections will be used. Any problem? Hello?
Yeah, sir, no.
Okay, actually.
Actually, there is some participants mute on, so I have a mic is on, so I have opted.
I'm sorry, I'm asking again and again because I was thinking that somebody is trying to ask some question.
No, sir, you continue.
So the patterns are stored in interconnections between neurons, similar to how this is the process, like how our human brain works. So there are heterogeneous association. For example, we can correlate English words to the German words. This is called as heterogeneous, as I told you earlier, that if you're connecting one input to another different kind of output, that is called as heterogeneous. Sometimes homogeneous or auto associations are where we are connecting same input with the same output. So these are the associations method for which we can use neural network. So for heteroassociation means there is one more difference between auto association and heteroassociation. In heteroassociation, look at this example. If we want to train, this is our input S and this is our output T. So we want to form an association between S and T, right? So heterogeneous association means this S must be different from this T. Now the dimension of S and dimension of T may be different or may be same. So in heterogeneous association, if you are writing this 1 0 0 0, if you want to classify this 1 0 0 0 0 in class 0 0, this is called as heterogeneous association, because here the input is different and the output is different. Also, what is called as dimension. So dimension means number of variables used in input. So here you can see we are using 4 number of input values, and here we are using only 2 number of values. So this is a transformation which is converting 4 information into 2 information. So that's why it is called as heterogeneous association. This is one example. Another heterogeneous memory example is this 1 0 0 0 may be connected to 0 1 1 1. This is again a heterogeneous association because this input and this output is different, but here the dimension is same, right? So this is also a heterogeneous association. In auto association, the same value will be corrected at input and output. So when you are talking about auto association, so 1000 will be connected to 1000. So once the neural network is trained, so whatever I'm doing, actually I'm using some set of input and output values which I want to associate. So I will supply it in this neural network. So once the neural network is trained, so when you supply input, it will give you the correct class. So it can remember like to which output class this neuron was, this information was associated. That's why it is called as having some kind of memory. So for heteroassociation, we can use a simple two-layer network of following form. So we can use this one. So this is the example of feed-forward network. So we can use both feed-forward and recurrent neural network. So in some application, feed-forward neural network will work, and some application recurrent neural network will work. So here we are not having any kind of connection, feedback connection. So you can see this is a feed-forward architecture. So only two layers will be sufficient when you want to associate some input to output. So now we need to think, because we have to use the architecture, this architecture, like which architecture I should use in what kind of problem. So when there are two actually things, in certain problems it is very simple to recall the information. So once the network is trained, it is very simple to recall the same information. So when you pass 1000 in an auto associative network, it will produce 1000. So the output is same. So if in only one iteration it is able to recall the thing, then you can use feed forward connections. But sometimes in some networks it is not possible, because if you increase the number of training instances, the neural network starts forgetting the things. So if you want to improve the performance of the neural network, what you can do actually, you can supply some feedback connections. So if, let us suppose, if you are saying that, okay, what is the output associated with 1000, and if at the first instance it is giving you 01111, but this is not the class which you have stored in your neural network, it means it is not giving the correct output, right? So if output is not there in your output database, what you have to do, you have to use recurrent neural network. So what recurrent neural network will do, it will refine this output again and again until it becomes this same input. So this is the difference between feed-forward neural network and the recurrent neural network architecture. So we can also use recurrent neural network architecture. So let us see. So sometimes it is possible to obtain a training set with, okay, one more thing, whatever instances you want to train with the help of neural network, you have to see whether they are orthogonal. Orthogonal means they are forming 90 degrees angle with each other. If that is the case, you can use some learning technique. Okay, and sometimes it is not necessary to even train the neural network, because this, like for example, in general, we use have learning method for setting association, or delta rule perceptron learning method for defining association with the different data values. So sometimes there might be some problems where you don't need any training, you have to define the weights, and once you have defined the weights, when you supply some input, it will produce the correct output. But sometimes you have to use some memory, because of actually if your input values are not orthogonal, then they will create some kind of crosstalk. Crosstalk means that network will not able to produce the correct output at the given input. So this is called, this case is called as creating forming a crosstalk. So that is happening due to some noise which is occurring in the interconnections. So in that case, you have to use recurrent neural network. So if your input vectors or if your input information is not orthogonal, then you have to use recurrent neural network, because there might be some crosstalks due to which you will not be getting the correct output in one iteration. So more number of iterations will be required. So you have to pass the output information again to the neural network. So again it will be refined. This process will be used again and again until you get a recognized output. So that's why we need to see what kind of connections are there in between input values. So if input values are not orthogonal, then we have to supply the recurrent neural network. Okay. So this, hello. So this is the method for producing output. So in general, we have to define this weight matrix. And Rajita,
Sir, yeah, somebody mic is on, sir. I'm offing it.
Okay. So this is the example.
Sir, this is I have a question.
Yeah.
So when we say the feedback and the input is remembered, the feedback. So what exactly happens? Does it stored in the key value kind of pair, or is it the weights are adjusted? What exactly happens when you saying it's remembering, or
weights again? Actually, what is happening in normal feed forward network? What is happening? Actually, you have to define this kind of method. This is the feed forward network, right? So what is happening once, let us suppose we want to form an association between 100 and 100. This is called as an auto association problem, right? Are you getting this one?
Yes.
So how you will be achieving this one? This one you will be achieving by training. So once this neuron is trained, how this neural network is performing this task. Actually, it will create a neural net, this weight matrix. Okay. This weight matrix will be created, and once you supply these information, it will produce the correct output. Any problem with this one? Let me know.
No, sir. Got it.
So what is happening actually, once you supply different input and output values, this network will be trained. And what is the meaning of training? It will fix the weights, right? So once you supply input value, it will try to associate it with the correct output. Now what will happen if there is a crosstalk? Crosstalk means, let us suppose, for example, if let us suppose, yes, what is happening, we want to create this neural network. Although this example is different, here we are not using recurrent neural network, right? I'm giving you a simple example. Let us suppose if I want to associate this 100 with 100, right? And then I want to associate 111 with 111, right? And I want to associate 000 with 000. So these are the training instances which I want to use for training this neural network, right? So what will happen if these instances are orthogonal? Orthogonal means if they're forming 90-degree angle between like in pair, right? Then only feed forward network will be sufficient, because it will be able to recall to which network, to which value it is associated. Any problem?
No, sir. Good.
Now what will happen if your input networks, if whatever vectors you are using for training are not orthogonal, right? So what will happen in that case, this network will not work. The reason is some crosstalk will appear. So for example, if you have used a recurrent neural network which is trained for producing 100 output for 100 input, 101 output for 101 input, right? What will happen? It will remember some output. Let us suppose we have already trained our this network, and it can learn these two values 100, 101. So when you supply 100, it will connect 100 with 100. Now the question is, what will happen when you supply if these vectors are not orthogonal? What will happen when you supply 100? It will not be able to associate this value with 100 in one iteration, right? One iteration means when you pass this 100, it may connect it like 101 with 101. The reason is due to crosstalk. Okay, some noise will appear on the output. Okay, so you because your network is not having any such class like 101 in this example. Sorry, 101 is already there. So let us suppose 100. Look, if 100, if I am using this network for training 100, so 100 is connected to 100 and 101 is connected to 101. And let us suppose if these input vectors are not orthogonal, then what will happen when you supply this information 100 in this neural network, right? So it may produce a different output which may not be there in your memory. Like it has only two output like 100, 101, but this 110 is not there in the existing output. So it will not be able to recall like to which pattern this 100 is associated. So this problem occurs due to crosstalk, which is actually occurring due to the problem because these vectors are not orthogonal. So if your vectors are not orthogonal, then what you have to do? You have to use some feedback connections. So what feedback connection will do? So once you get 100, when you supply 100 and when you get 110 output, it will check from the remembered output whether it is getting the correct output or not. If it is not getting the correct output, this output 110 will be passed as input again, and this vector will be trained again, right? And this process will be means it will be used again and again until you get the correct output, either 100 or 101, but whatever the network has remembered. So in that case, you have to use recurrent neural network. So what you are doing actually, when you are supplying input, you are not getting the correct answer, but you want to associate this answer with the correct answer. So whatever it has remembered, if you want to associate with the correct answer, you need to supply the output again to this neural network. So that we do in recurrent neural network architecture.
Okay.
Is it good? Are you able
yes.
to understand?
Yes, sir. Thanks.
Any other problem? Okay. So we were talking about like what kind of learning we can use. So I told you that you can use, there are two standard learning methods which we can use for training neural networks. One is called as have learning and another one is called as perceptron learning method. So these are the two existing learning methods, which I think you have already learned by some other experts, because I saw that there was a session on artificial neural network. Anyway, so I have already
Sir,
told
I
you.
have a question. Can I ask?
Yeah, definitely.
Sir, sometimes we have a competitive learning. Sir, actually, I want to know about that learning. What is the purpose of that learning actually?
Okay, competitive learning is required when you have like very similar kind of outputs and you want to produce, let us suppose, although that topic is not relevant to this one, but I can tell you, let us suppose if this is the input layer, right? And this is the output layer, right? So let us suppose if we want to learn, if we are passing 100, right? And if we are getting 1, 2, 3, right? So we are having, we have used three output layers. This is O1, this is O2, this is O3, let us suppose. So in competitive learning, what will happen? It might be possible that 3 output will be produced for the same input pattern, right? But you don't want to produce all the 3 outputs. You want to prefer only one output, right?
Yes.
So for that, you have to use some kind of learning which will only highlight one output and it will not highlight other outputs. So that is called as computative learning. So let us suppose if I am passing input as this A, right?
Yes.
If my input is A and as a output, if I'm getting A, H, right? Or this thing, this symbol. There might be some cases when you want to recognize a character, this A may resemble to H, because what you have to do, actually, you have to create separate patterns, right? If you want to train this character, if you want to create a neural network, okay, which can learn, recognize this character. So how that can be done? Actually, for that, you have to create patterns in the form of 1 and 0, which once learned can give you output, like it may produce output A, it may produce output H. So similar kind of characters may be produced. So the network may produce it as A, it can produce as H, because these characters are very similar to each other. So if 2 outputs are possible, you have to suppress, you have to discourage one output. So that is called as computative learning. So in that case, you need to decide, okay, this character is A, so I need to produce A. So that is computative learning, right? So when more than one outputs are possible, and if you want to produce like which output will be more probable, then you can use computative kind of learning.
Okay, sir. Okay. Thank you, sir. Thank you.
Okay, so we are talking about this one. Any other question about this? So although it is not possible to cover entire thing in this short time span, because my lecture is about only 1 and